All right, now we're on to the last type of problem in Chapter 9, and that is excess. How much excess would there be of the other reactant? So, what is the other reactant when we're talking about French toast? What is that other reactant? Because we're talking about the limiting reactant was the milk. What is the other reactant? Anyone? The eggs. So the question is, how much eggs is left over? So start with the limiting reactant, always with excess. So I'm going to start with my amount of limiting reactant. My limiting reactant was the milk. So I'm going to go ahead and start with my milk, because these ratios hold true not just for reactants and products, but also for reactants and reactants. If I use that much milk, I'm going to try and figure out how many eggs I used in that process, because my ratio is 4 eggs for every 1 cup of milk. And if I calculate that, how many eggs were used? What's 2 1/4 times 4? Anyone? 9er. We have 9 eggs used. The question is not how many eggs were used. The question is how much is left over. The 9 is going 2.25 times 4. So by using all my milk, I would use up 9 eggs at the same time. How would I figure out how much is left? What would I subtract that from? 10, my original amount. 10 minus 9er. And I'd end up with 1 egg extra, or in excess. There was a band called In Excess back in the 90s. And they did capital letters like that. Not bad. We'll play some In Excess here in a little bit, so you know. How many people have heard of that band? Caleb? Oh, a few of you. Nice. Nice. Not a bad band. Lead singer died. They had a reality show a couple years ago looking for a new lead singer. I don't think it really panned out, though. But anyway, we can do the same thing with chemical reactions. So let's do that same thing, and we'll call her done, and you'll get some time here to work on some homework. So go ahead. It's on the board. So of the other reactants, again, I'm going to start with my limiting. My limiting reactant is DNS, and my amount of limiting reactant is 46.5. Now, while this gives us another stoichiometry problem to solve, the good thing is, if you ever have to do excess, you already have all of these masses someplace, because we already had the masses from number 1. So ZNS, 1 mole of ZNS. I have the molar mass is 97.48. Here I'm going moles of ZNS. And while you have to set up a problem, at least you already have your numbers. And now you go moles of oxygen, 1. Those are for my balanced equation. Moles of oxygen, 1. I'm looking for grams of oxygen. Because my goal here is to figure out how much of the oxygen that I started with, how much of that oxygen I started with did I use up? And then I can figure out how much I have left over in that case. And if I do this math, see how we're canceling everything out? It's a gram-to-gram equation. Those cancel. We're always canceling diagonally still. And if I solve for grams of O2 used up, I get 7.63 grams of oxygen used. And I put the word used there for a reason, because a lot of people, when they do these problems, want to put 7.63 and just leave that answer. But that's not the answer. The question is how much is left over. How much did I start with, Jack? How much oxygen did I start with? 13.3 grams. Thank you. 13.3 grams that I started with. I subtract that from the amount that I used, 7.63 grams. So I start, I used, and then I can figure out my in excess. It's a band. 5.7 grams of oxygen. The reason that it's only 1 number past the decimal is because it's 13.3 is only 1 number past the decimal. The 6.3 is 2 numbers past. Remember sig figs with subtracting, you can only go the least number past the decimal. little wonderful blast from the past there with sig figs. And that is excess.